A cable from Earth to space, 96,000 kilometers long. Japan says they can build it. Every rocket launch burns $5 million of fuel just to reach orbit. Most of the rocket is destroyed every single time. That's how it works today.
What if instead of burning a rocket, you just rode a cable straight up? That's not science fiction anymore.
Obayashi built Tokyo's tallest tower. Now they want to build into space. Their plan, a 96,000 kilometer cable and a floating port. The elevator uses electricity. No fuel, no explosion, no single-use hardware. One material makes or brings the entire plan. It hasn't been invented yet, not at scale. Shizuoka University is testing it right now in space, on the International Space Station. That test sample is what stands between a concept and a construction site. Each plate bent to the exact radius of a 400-meter floating ring. "24 watertight compartments, each one welded shut before the next begins." Every compartment flood tested before it leaves the yard. One leak, and the port sinks. Underwater welders seal the base joints. The weld must hold at sea for decades. Inside each compartment, ring frames every 2 meters. The hull can't flex, or the cable mount fails.
Ballast concrete poured into base cells. 48,000 tons to keep the port from tipping.
From inside the hull, it feels like a submarine.
That test sample is what stands between a concept and a construction site. "12 thruster pods fitted to the hull. These steer a 400-meter ring in open ocean. The deck goes on last, prefabricated in sections, lowered, aligned, bolted, welded flush. Lightning conductors ring the full deck. The cable will be the tallest object on Earth. Lightning will find it. The mooring chains alone weigh 6,000 tons, each link forged from high-strength alloy steel. The hull leaves the yard. Workers line the deck as it moves into open water for the first time.
Panel seated.
Confirmed. System check is green. The terminal tower rises from the center of the ring, 60 meters of steel lattice, straight up. Sensors on every tower leg. If the cable vibrates, every movement measured from the first second. The climber loading dock takes shape. Guide rails, locking arms, built for a 100-ton vehicle docking at sea.
Everything built here is for one thing: to grip that cable when it comes down from orbit and never let it go.
A city lives on this platform. Desalination plant, power generation, sewage treatment, all going in simultaneously.
The laser transmitter dish assembled on deck. When the climbers ascend, power beams up from here.
The cable entry seal fitted around the tower slot. Storm seas will try to flood this opening. They won't.
Helideck finished on the aft section, the only way on or off in an emergency, or for regular crew change.
Control room fitted out, every screen, every panel fixed. Port operations run from here permanently. Fall arrest rails on every walkway. Equatorial storms don't stop for the deck crew. The Earth port reaches station. Thrusters fire, chains tension. Workers watch the gauges and hold. The cable starts here. CVD reactors growing carbon nanotube fiber, atom by atom. Fiber drawn off the reactor onto a collection drum, uniform, continuous, defect-free, or it starts again. CNT fiber twisted into yarn, hundreds of fibers combined, twisted, not just bundled, for load sharing. Yarns bound into ribbon, Heated rollers press the polymer matrix through. The ribbon takes its final form. Protective coating deposited on every surface. Without it, radiation strips the carbon bonds in months.
20 tons of this. That's the seed cable. It weighs less than a truck. It has to hold more than a skyscraper.
Ribbon wound onto precision spools under controlled tension. One kink, and that section fails on deployment. Each spool sealed in inert gas transport canisters. Oxygen degrades the ribbon. It travels in nitrogen. At the launch facility, each canister inspected on arrival. Then it goes into the clean room. Canisters mounted in the spacecraft, deployment mechanism hand-cycled by workers, every release tested before it goes vertical. The deployment spool motor and brake installed. This controls how fast the ribbon falls toward the port below. Fairing closed over the cable payload. 20 tons of CNT ribbon, ready to ride a rocket to orbit. Final deployment system check. Every sensor, every drive. Workers run the list line by line before handover. The rocket takes on propellant, 300 tons of liquid oxygen. Workers watch every gauge. Service arms retract. Workers clear the pad. The rocket stands alone, ready. Ignition. The cable rises on a column of fire. First stop, geostationary orbit. First stop, geostationary orbit.
Separation in orbit. Thrusters fire. The spacecraft orients. Below, 36,000 kilometers of nothing.
The spool starts turning. Ribbon feeds out, down toward Earth, up toward the counterweight above. Ground crews track the descent on radar. The ribbon is thinner than a human hair, falling 40,000 kilometers. On the port, the capture crew at stations. Days of watching. Then the ribbon enters radar range below cloud. An aircraft snags it above cloud. Workers lower it to the deck. The ribbon touches the Earth port for the first time.
Workers thread the ribbon into the tensioning drums, manually, carefully, one guide roller at a time.
Tension applied. The ribbon goes taut from the Pacific Ocean to geostationary orbit, one continuous structure. That thread disappearing into the sky above me is the longest structure humans have ever built.
And it took one rocket to put it there.
Ribbon anchored to the drum clamps. Workers torque every bolt. The load cells hold steady. It's not going anywhere. The weather enclosure sealed around the ribbon entry. Salt spray will destroy CNT. Workers close it out. Control room confirms. Ribbon stable, port holding station. The seed cable is in place. Now it has to grow.
Japan imagined this only on paper. We brought it to life.